arithmetic progression and geometric progression, most students can do them separately, but this question puts them together, and that's where 12 marks quietly disappear. This is Additional Mathematics Paper 2, variant number 3, May-June 2025, question number 9. The first term of arithmetic progression is 9. Let's write that down. Arithmetic progression, the first term, which is A, is equal to 9. The last term is 159. That is L equal to 159. The sum of all term is 2604. So Sn is 2604. Arithmetic progression is increasing by additional or subtraction. So you have the first term, second term, the third term, and so on until the number nth of the term. Now, in our question, we know that A is 9 and the last term, which is given, 159. The third information given is the sum of all this term added together will be equal to 2604. Before we try to solve this, let's complete the information for arithmetic progression first. For example, we don't know the terms for the last progression. In order for us to do that, we can use the formula given in the list of formula, which is Sn equal to n divided by 2 bracket the first term plus the last term close bracket. So we know that our sum of the term would be 2604, and we wanted to find our n over 2. The first term given is 9 and the last term is 159. Solving n, we will get 2604 equal to 84n. Hence, n is equal to 31. What does this mean? It means that our last term is term of 31. In arithmetic progression, you need to have d, or common difference. Let's find d using the formula of the term. Un equal to the first term plus n minus 1 times the common difference. Term of 31 is 159 equal to the first term is 9 plus 31 minus 1 and times the common difference. Hence, this one will give me 150 equal to 30 times d. Hence, our d, or our common difference, will be equal to 5. Now, the important information about arithmetic progression is complete. The 12th term of this arithmetic progression is the first term of geometric progression. Let's write that down. The 12th term of this arithmetic progression is equal to the first term of geometric progression. Let's find the 12th term using arithmetic progression formula. So 9 plus 12 minus 1 times 5. That is equal to our first term. Simplifying this, our first term will be 64. The second information is the 8th term of this arithmetic progression. So the 8th term of the arithmetic progression is equal to the second term of the geometric progression. So second term. Now let's do the same thing. Let's use arithmetic progression formula to find the 8th term. 9 plus 8 minus 1 times 5 equal to the second term. So simplifying this, our second term is equal to 44. Let's finally go to the question. The question is asking us to find sum of the first 6 term. Now, for a geometric progression, we already have the information about the A, and we have the information about the second term, which is 44. The next important information that we need to find first before we solve the question is R, or the common ratio. To find the common ratio, it's second term divided by the first term. So 44 divided by 64, that is equal to 11 over 16. Now S6, Sn for geometric progression is equal to A 1 minus R to the power of n divided with 1 minus R. Since we already have all the information needed, so A is 64, 1 minus 11 over 16 to the power of 6, close the bracket, over 1 minus 11 over 16. Now put this in your calculator, you'll get 183.17. Now if you read the instruction, you need to give your non-exact numerical answer correct to three significant figure. Hence, we're going to leave our last answer in three significant figure, which is 183. Now let's bring in the marking scheme. This is 7-mark question. The first mark is when we understand n is equal to 31, and we use the formula where n over 2 a plus the last term is equal to 2604. That's going to give you 2 marks. So this is 2 marks. And when you get d equal to 5 with this or using this, that is going to give you 2 marks. So this is 2 marks. And when we reach r equal to 11 over 16, that is also 2 marks over here. And when you get to your last final answer, 183, this is a 1 mark. Accepted answer also 183.2 or 183.17, which is this one. Question B, geometric progression. The first term is sine theta. Common ratio is cos theta. R is cos theta. And this is the range. Show that the progression has sum to infinity. For this 1 mark question, you can refer to the list of formula for geometric progression. For sum of infinity, the condition is modulus r must be less than 1. Sum of infinity, modulus r must be less than 1. In our question, our r is cos theta. So cos theta modulus must be less than 1. Let's prove that for the range between 45 degree to 135 degree, cos 45 is equal to 0.707 and cos 135 degree is equal to negative 0.707. Now, we know that it must be less than 1. So the condition is cos theta must be in between
negative
1 to 1. That's how we show that this progression has sum to infinity. Let's bring in the marking scheme. This is B1 mark. When you show cos 45 equal to 0.7, and then when we show cos 135 is equal to negative 0.7, and we make a conclusion that cos theta is in between negative 1 and 1, which is this one. Hence, we're going to get our B1 mark. Question 2. Show that sum to infinity can be written as cosecant theta plus cotangent theta. From the formula list, we know that sum of infinity equal to a over 1 minus r. Let's write that down. And from question 1, our a is sine theta and our r is cos theta. Let's substitute this in our equation. Sum to infinity is equal to sine theta over 1 minus cos theta. Our goal is to change this sum of infinity to cosecant theta plus cotangent theta. Now we have sine at the top and we have cos at the bottom. And from the identities, we know that sine square theta equal to 1 minus cos square theta. And to simplify this fraction, let's times its conjugate. I'm going to times its conjugate, so 1 plus cos theta, and at the top also 1 plus cos theta. Now let's simplify this. I'm going to get sine theta times 1 plus cos theta over, at the bottom, what's left is just going to be 1 minus cos square theta. Now, since we know that 1 minus cos square theta is going to be sine square theta, I'm going to substitute that in our equation over sine square theta. We can now simplify sine theta, and what's going to left is 1 plus cos theta over sine theta. Now let's separate this fraction. We're going to get 1 over sine theta plus cos theta over sine theta. And we know that 1 over sine theta is equal to cosecant theta. We also know that cos theta over sine theta is equal to cotangent theta. Now let's just substitute that equal to cosecant theta plus cotangent theta. That's how we show the sum of infinity can be written as cosecant theta plus cotangent theta. Let's bring in the marking scheme. 9b2 method M1 mark is given when we substitute that into the formula of S infinity. This is M1. When we try to simplify the fraction by times its conjugate, this one is A1 mark. When we try to simplify 1 minus cos square theta with sine square theta, that is A1 mark. And when we get to our final answer over here, that is A1 marks. So this is 4 out of 4. So that's question 9 for 12 marks done. Subscribe if you want the rest of this paper. I'm posting one question at a time. Drop a comment below if you got the sum to infinity part. It's the one most students skip. And if your friend is sitting for the coming exam, share this with them. Bye!